All right, hello. So welcome to the third video on trigonometry. Today we're finally going to be talking about the graphs of these functions that we've been working with for 2 videos. And we're also going to discuss some pretty basic properties that come from those graphs. So without any further ado, let's go ahead and get started. Okay, so to start off with, we're going to be talking about sine and cosine. All these functions today that we're looking at, we're going to be talking about those functions in radians, right? Which means that the input, the angle, is not in degrees, it's in radians. Although if you put it in degrees, many of these same properties would still be true. Okay, so here is the graph of sine. Remember the definition that we've been talking about for a couple videos, right? So if the input, our x variable, is also theta, right? Theta, that angle. And so what the function says to do, right, is find the point on the unit circle. And if you're looking at sine, you're going to be looking at the y coordinate of that point. And if it's cosine, then you're going to be looking at the x coordinate. And that, whichever coordinate, that would be your output of the function. Okay, so much about these graphs should be pretty straightforward, even though we haven't seen these graphs yet, right? So what I want you to think about is, for example, if I plug in theta equals 0, think about that point on the unit circle, think what its coordinates are, and that should lead you to conclude that the sine of 0 should be 0, and cosine of 0 should be 1. Okay. Then think about what happens when you start increasing theta. The y coordinate's going to go up, and the x coordinate is going to go down. Okay, and because the point is moving around the unit circle, that means that we're getting this repetitive nature of the graph, what we're going to call periodicity of the graph, a little bit below. Okay. So these are graphs that we want to be really familiar with. There's no new information here. This is all coming from the definition we've already talked about. But we do want to be familiar with these graphs separately from that definition. Okay, so let's go over some properties that this reveals to us. First thing we can talk about is domain and range. We've talked about these things for all the functions that we've looked at before. Both sine and cosine, I can plug in anything I want, right? Any angle corresponds to some point on the unit circle, and that point will always have an x coordinate and a y coordinate. So the domain is everything, in other words, minus infinity to infinity. The range, however, because we're stuck on that unit circle, is minus 1 to 1 inclusive, which means minus 1 to 1 with closed brackets. Okay. So these functions both have this property that we haven't seen in functions before. They're both periodic. Okay, what that means, when a function is periodic, and in this case the period is 2 pi, that means that the function repeats every 2 pi units. So if I add 2 pi to x, both sine and cosine are going to repeat. Both sine and cosine are going to repeat. Both sine and cosine are going. Whoa, okay. So let's move on. All right, so sine has this property that is called odd. That's a property we haven't talked about yet. You may remember it from previous classes, but what it means for a function to be odd is that when you plug a negative value in for x, you get negative what you would have if you'd plugged in the positive value. And looking at this, I realized that I actually made a mistake. I said exactly the opposite, wrote exactly the opposite of what I said. But what I meant to say here is that sine of minus x is minus sine of x. Okay, so that means negative thing goes in, and you get out negative what you would have had otherwise. Okay, so why do we call this odd? Because it's exactly the same property that odd powers of x have. So if you think about functions x, x cubed, x to the 5th, those polynomials, they all have this property that if you plug in negative, so for example, plug in negative x into x cubed, and what you get out is negative outside of x cubed, right? So they all have this odd property. That's where that name comes from. Okay. Cosine is what's called an even function. It has the opposite property. That means that if we plug in a negative value in for x, we get exactly the same thing as if we'd plugged in the positive value. There's kind of perfect symmetry, right? We can see both of these properties in the graphs themselves, right? If I imagine with cosine, I have this symmetry where if I flip everything around the y-axis, I get exactly the same graph. Okay, but with sine, I don't have that property. If I imagine flipping everything around the y-axis, then I would get kind of the opposite function of what I had before. I'd get negative the function that I had before. Okay. All right, now if we put these two graphs together, we see something kind of interesting. We see that they're almost the same function, right? They both have so many similar properties. They're not the same function, but we can see that one function is just a horizontal shift of the other, okay? This means that for modeling purposes, the functions are almost interchangeable, right? You could pretty much start modeling it with either one or the other, and if you just do the right transformations, it doesn't really matter because you can turn one function into the other pretty easily. Okay, in formula form, here's what that means, right? So the blue graph is cosine. If I shift that to the right by pi over 2, I get sine. Similarly, if I shift sine to the left by pi over 2, I get cosine. But remembering our formulas from graph transformations, which it's been a while, so you may want to look that up, that means that sine of x plus pi over 2, that's shifting it over to the left, sine over to the left by pi over 2, I get cosine, and cosine of x minus pi over 2, remember that's shifting it to the right. Remember that horizontal transformations are a little bit backwards, right? I get sine of x if I do that. Okay. All right, so tangent is quite different than both sine and cosine when it comes to the graph, all right? So here's the very strange graph of tangent. Doesn't look much at all like sine or cosine, but it does have some similar properties. So let's talk about domain and range first, right? What is tangent? It's sine divided by cosine. And whenever we have a function that's a fraction, we have to be worried about dividing by 0, right? That's going to be where we have to maybe take something out of our domain so that we don't ever divide by 0, right? Well, if it's sine divided by cosine, then we've got to worry about cosine being 0. And if you go back and look at the graph of cosine, or just think about it on the unit circle, then you realize that cosine is equal to 0 exactly at pi over 2, 3 pi over 2, minus pi over 2. And if we start looking behind a pattern behind those numbers, and we might realize that that's all numbers of the form pi over 2 plus pi times n, where n is any integer, positive or negative. Okay, so this is a domain unlike any we've seen before. I can't put this in interval notation very easily because it's infinitely many intervals. The best way I know of to write it is all real numbers except numbers of the form pi over 2 plus pi times n, where n is any integer. Okay, and if you notice on the graph, that's all the vertical asymptotes of this graph. This graph has a lot of vertical asymptotes, infinitely many, in fact. Okay, range is easy, though. Range is minus infinity to infinity. Tangent can be anything I want, because even though I'm stuck on the unit circle, the slope, or y over x on the unit circle, is not limited. It can be as large or as small as I want. Okay, tangent is also periodic. However, this is kind of interesting. You might have guessed that the period would be 2 pi, like sine and cosine, because after all, that's when you get back to the same place on the unit circle, when you add or subtract 2 pi. However, in fact, the period is actually smaller than that. It's pi. So I'll let you think about that on the unit circle, because there's a nice explanation on the unit circle. But what that means formula-wise is that tangent of x plus pi is the same thing as tangent. Okay, Tangent, like sine, is an odd function. And that means that, I got the formula wrong again, tangent of minus x is the same thing as minus tangent of x. Okay. And I'll let you think about that, but what that means, one way you could explain that is if tangent is sine over cosine. If I put minus x into sine over cosine, the sine is going to flip signs, but the cosine is not, because sine is odd, cosine is even. That means that the numerator is going to change signs, but the denominator is not. So the whole fraction is going to change signs. All right. So for homework for today, I have something a little bit more abstract than I usually ask, but this is going to hopefully get you referring back to those graphs and thinking about them just a little bit more deeply. Shouldn't take you too long. I would like you to find all the values of x such that sine of x equals cosine of x. Okay, and I'd like you to go further and explain your answer in two different ways. One way using the graphs of those functions, and in fact, you might scroll or rewind this video until you get to the part where both the graph of sine and cosine are on the same axes. That should give you a pretty short answer to this question when you look at that. The second explanation, I'd like you to use the unit circle definition. Okay, so explain to me, knowing what you know about the unit circle, what the angles you'd plug in to get sine equal to cosine. And both of those should lead you to the same answer. Okay, great. I'm glad that this video is a little shorter than the last two. I hope you have a great evening, and I'll see you in class.